We start with the preprocessing, which computes the signed distance transforms and the high-density clusterings for the ensemble isocontours of all isovalues. This can be done offline, but we include it here to give a sense of the performance of the whole system. The simplified spaghetti plot shown on the left renders the representative isocontours from each isovalue and provides an overview of the positional variability of isocontours across multiple isovalues. A thick representative isocontour indicates its member isocontours have a large variability and vice versa. From this overview, we can select interesting isovalues for detailed exploration. For example, we can left-click to select isovalue 5000. In the mode plot, we can brush the modes to select different solutions, and the corresponding isocontours are highlighted in the spaghetti plot. We can also do high-density filtrations to select high-probability solutions at different density levels. We can specify density rank percentiles to generate solution galleries at different percentiles. After we finished exploring the isovalue, we can right-click and go back to the simplified spaghetti plot to select other isovalues. By selecting the two trends, we notice that they mostly differ in the south areas while the variations and topologies in the north region are not apparent. So we brush the spaghetti plot to select the north area for regional analysis. After reclustering, we notice that the dominant trend is still composed of isocontours with various shapes and topologies. This is because of the high variability of these isocontours, makes it difficult to form significant clusters that have more than 3 members. To further separate these isocontours, we relax the significant threshold to 2 and redo the clustering. Selecting the trends, we observe solutions with different topologies or phases. We can also do high-density filtrations to predict the isocontour's topology for the selected region. Now, we select the isocontours that have multiple possible trough locations. Looking at the spaghetti plot, the overlapping isocontours makes it difficult to compare the strength of different trends, while the mode plot clearly shows the dominance of the red mode. The overlapping of the red isocontours and blue isocontours is because they have different variations in the eastern region. Therefore, we brush the spaghetti plot to focus on the local variability of the trough. The mode plot shows 2 close strong trends and 2 outlier modes. We can also visualize the local clustering for the global isocontours, where we see the clusters of the ridges in the eastern regions are mixed. On the other hand, the local clustering on the eastern region also does not well classifies the middle trough. Let's explore more isocontours.